Right. So hi everyone. Might feel a little low, my tone today. It's mostly because it's a little late right now. I'm slowly moving my sleeping pattern up a bit. So by next week, basically, we should be fine. This week, so this is now the time where it would be good for you guys to start to become slightly more independent, especially the people who have been following the classes. I know a bunch of you are lagging behind and still at anywhere between week 3 to week 12, and if that's the case, it's fine. But this is the week around which I would basically urge everyone to look at projects a little ahead, look at topics a little ahead, and start to look at open source projects as well. The thing that we're discussing today is probably the biggest blocker you would have if you try to go through the cal.com codebase. The cal.com codebase uses trpc. It is something we haven't discussed until now, and if you open that project, one of the places you'll get overwhelmed at is the backend, because the backend uses trpc. That's what we're going to cover today, and maybe tomorrow I'll take you through a bunch of cal.com files and sort of their code base, and we'll understand how easy it is to understand their backend if you know this thing. But if you do not know trpc, then of course it will be a little harder. It is a moderately hard concept, although this is something that you can very well pattern match if you've done backend before. So if you have written express servers, it should be able to thoda pattern match and understand, this is what is happening, this is how we're creating our backend. But it is slightly advanced, not too advanced, because backends are usually easier to understand than frontends. If you go from vanilla HTML, CSS, JavaScript to React, if you go from React to Next, those are slightly harder. Backend systems are generally easier to understand. So even though the thing that we're discussing today is new and is sort of hard, I feel that most of the people should be able to get through it. Again, as always, we will keep taking polls, and we'll try to sort of maintain the 85% percentage, because this is a hard concept. And we'll do a very big checkpoint in the middle. So we'll understand the basics very well first. We'll do a checkpoint, and then only after 85% proceed do we move to the advanced stuff. This week completely is for trpc. So there are some basic things to cover today, and maybe some advanced concepts, and tomorrow we'll cover basically the rest of the things. That will be the general flow of this week. Let's get right into it. So trpc is not used in any code base, especially the code bases that we'll be looking at, but cal.com does use it. So this, you could say, is a niche technology, is a neo technology, but the goal of this week is one, so you can go through cal.com code base. Without this you won't be able to. Two, start to getting out of our comfort zone a little bit, because this is that one technology that might differentiate you from other engineers, or that might filter out a good crowd when it comes to some open source projects. Every open source project might have one or two technology like this. For example, if you look at Backpack uses GraphQL. If you look at cal.com, they use trpc. If you look at dub.sh, they use an analytics engine, which I guess won't be too difficult to understand. But every project, other than the basics of MERN, which is frontend in Next.js, backend in Node.js, and Prisma as the ORM, and maybe SQL or Postgres as the database. Other than all of this, there are usually some small niche technologies, niche libraries that they are using. Our goal is to now be able to understand, can we learn these either on our own? Right now, I am here to guide you, and we're doing this together. But at some point, you'll have to start to learn technologies yourself, and that's sort of the inflection point that we're trying to reach. Again, if you've not followed along the course until now, then don't worry about any of this advice. But if you've been working well, and if you've followed along completely until week 13 that we're at 14 now, if you followed along until week 13, then at this point I would urge you to create a lot of projects and start to dive deeper into technologies, new technologies, the things that we're going to learn in the next few weeks. Try to understand them yourself and see if you're able to. All right, cool. Let's get right into trpc. Big question is, what is trpc and why trpc? So focus on the last three letters here, RPC. It's a very common term used, and it stands for remote procedure calls. What does that mean? In our backend systems, generally when you're writing even lead code problems, you define functions, right? These are also called procedures. And remote procedure call basically means if I can call a function remotely, that's called a remote procedure call. Let's try to understand that on a diagram. Until now, this is how our backend systems have worked. There has been a backend HTTP server, and you've had, let's say, a front end in React or Next.js. Your front end sends what kind of requests? It sends HTTP requests, or what are called REST requests, which have the type of the request, some body, sometimes some headers, and the server responds back with some response. This is the communication that we have done until now in a very basic full stack system, where you have the front end written in React, back end, let's say Node.js. You send an HTTP request, you get back a response. This is what's called REST or HTTP. But there are some nuances to learning this technology. You need to know what is GET, what is POST. You need to understand the HTTP protocol well. Wouldn't it be nice if there was a backend system? It had a bunch of functions, for example, create to do function and create user function and delete to do function. And you could, in your React front-end code, simply call create to do and send arguments there, title, description, without understanding the HTTP protocol. Wouldn't that be nice? Arguable whether this is nice or not, because most websites still use HTTP, and as a backend engineer, you need to understand the HTTP protocol. But let's say you did not want to. In that case is where remote procedure calls come into the picture. What are remote procedure calls? Basically means you're calling a function on another server and getting response from it. Under the hood, it still uses HTTP, it still uses maybe some other communication protocol. There is no way for you to, call a function here natively. If I'm on this server and I called create to do, then you're sort of, if you look at the assembly code, you're making a function call to that specific function, for example, create to do function, and your call stack is going there, and then the function is getting executed. You can't really do that remotely. You are effectively sending an HTTP request. Only your client, or like the library that you're using on the front end in your React application, has very nice functions. For example, create to do function. You just call the create to do function. It does an underlying HTTP call, which you as the application developer don't have to worry about. That is what remote procedure calls stand for. You have under the hood still using HTTP, but you as the application developer, you as the front end developer, only call create to do, which does what's called a remote procedure call. And you don't have to understand, okay, what is get, what is post, what is body. You call the function name, you send the right set of arguments. Under the hood, everything happens, and that is what is done by the RPC library. In our case, the library that we are discussing is called Trpc, but there are various libraries that do the same thing. Another very famous one is called grpc, which I think is written by Google, which lets you do almost the same thing, which is on your server you define functions, on your client you simply call a function, and you don't really understand the underlying communication protocol and how the request is actually going out, how you are receiving the response. All right, that is what RPC is. Trpc is a library written in TypeScript that lets you do remote procedure calls, which means you write your backend code in a way where your functions are sort of exposed rather than HTTP endpoints being exposed. Again, under the hood, HTTP endpoints are being exposed, but you would never worry about that. You as the application developer write some functions, and then on your client side, you simply call those functions. Under the hood, the requests happen. This might feel very similar to, if you remember from the, never mind, I was giving the OpenAPI class example, but let's not do that. Remote procedure calls, what is it? You write your backend, you write a bunch of functions, you go to your front end, you can call those functions. But to facilitate this, you need a library that sort of auto-generates this front end code where you can call these functions, and also gives you, as the backend developer, all the tools to write these backend functions, and that's what Trpc lets you do. All right, let's look at some features of Trpc, and then we'll try to just start coding and get right into it. Trpc's pitch is, okay, we have automatic types on front end and back end. What does that mean? if until now you might have remember, we have written Express backends and we have written Next.js frontends. Whenever we write a route similar to this, let's say app.get/todo, we get some input from the user. If you might remember, we have used Zod in the past for input validation here. This is how we write front-end code, backend code. And here we can do backend checks and make sure that the user has sent us the right schema by using Zod. But on the front end, we never did validations. On the front end, we sometimes, if you might remember, were able to infer the type from Zod and then use that type on the front end. But we never really had very strict type checking on the front end. We only had strict type checking on the back end. Front end would simply do the fetch request and send the title and the description. That's not great. It would be good if the library that you're using in the front end gives you very nice types, and TRPC does that. You write your backend server and on your front end you get very nice types, how we will see very soon. Secondly, it writes generic. You have, as the application developer, when you're writing TRPC backend, let's say a to-do application, you write very generic code that can be converted into an Express backend using a command or like a simple auto-generate tool. It can also be converted into a Next.js backend. So these frameworks keep changing. Express was the primary backend framework, and people used to deploy it on AWS. Then suddenly Next.js came, and Next.js lets you deploy on the cloud for free and also deploys your servers on the edge. So people are like, now we'll write application backends in Next.js. The problem is a lot of big applications were written in Express. It's very hard to migrate from an Express backend to a Next.js backend. And hence, wouldn't it be nice if you just write your code once in TRPC and then you tell TRPC, bro, please convert this code and serve it as an Express backend, or please convert this code and serve it as a Next.js backend. So that's another big sort of feature of TRPC. You write your code once and then you can decide whether you want to serve it as an Express server, whether you want to serve it on an AWS Lambda, whether you want to serve it on a Next.js backend, and like a bunch of these adapters. It under the hood takes the pain of converting the generic code that you've written into Express or into Next.js. All right. Why TRPC for us? Cal.com uses it. It will be very hard to understand the backend code of Cal.com if you don't understand TRPC. So that's our goal for why we're trying to learn TRPC during this course. All right. Let's dive deeper into the second point. Let's say there's a to-do application you have. This is the backend code of the to-do application if you're writing it in Express. app.get/todo. Let's say there's a get endpoint, or probably a post endpoint where you get the title and the description. So assume this is post. What does this endpoint do? It lets you create a to-do. You get the title, you get the description, you do some database stuff, mongoose.insert the to-do, and then you return to the user some response. This is how you write a basic HTTP endpoint in Node.js, specifically in Express. In Next.js, this is how you do it. In your source/pages/API, whatever you define here, hello.ts, a.ts, api.ts, user.ts, can expose endpoints. And this is the way to do it, which is that you export a default handler or a default function where you run all of your logic, get the request parameters, do all the database logic here, and then return the response. This is how things are written in Express, and this is how things are written in Next.js. As I said, when Next.js did not exist, people wrote all their code like this. Now people are like, oh, Next.js backends are superior, so they have to convert all of this code to this code, which is very hard. That's where TRPC helps you a lot. Okay, you write your code once and then you can be like, bro, use this backend, use this backend. If in the future a new backend comes, someone will write an adapter for it and you'll be able to convert your generic code into that new fancy tech stack. How does TRPC does it? It does this by using something called as adapters, which is, let's say you are a company like Express.js or a library like Express.js or a library like Next, or there are a bunch of many other popular libraries that are written here. You can write an adapter and any existing TRPC application can be converted to your backend. So that's how they sort of created a base layer of writing APIs. Okay, this is how you write not exactly APIs, RPC functions. And whoever in the world wants to create their own HTTP servers can use existing TRPCs and integrate with that. So You as the application developer simply write some trpc code, which basically means some TypeScript code only, but you know, define very nice, this is my function, this is the input, this is the output, and when you're serving it, you can decide कि I want to serve it via express, or I want to serve it via next, or if there's a fancy technology, you can serve it via that. So this is code that never runs on a server. This is code that runs on a server. This is code that runs on a server. And this auto conversion is done by the trpc compiler, or more specifically the adapters. Your end user in your browser interacts with either this or this based on how you have deployed your backend, and you can basically use one of these many famous HTTP servers to deploy it. Each has their own benefits. Express is easy to understand, lets you deploy very easily to bare metal, AWS, all that jazz. Fastify is a famous auto scaling solution and lets you sort of pay only based off your pricing. AWS Lambda is a what's called a serverless solution where you pay very less, only pay based on per function usage, things like these. trpc gives you the benefit of writing code once and then being able to deploy in any one of these stacks, and how it does that we'll see very soon. All right, so these are the two benefits. What are the two benefits of trpc? If someone asks you this in an interview question, automatic types on front end and back end, which means you write your backend code once, you get very nice types on front end. What that means you will see very soon. Secondly, you can write generic code just once and it can be auto converted into whatever backend you want, so that if there is a new fancy backend technology in the future, a fancy backend HTTP server, a fancy way to deploy HTTP servers in a serverless fashion, in a auto scaling fashion, in a new cloud, trpc will take care of it. Someone in the community will write such an adapter for it, and you can simply migrate your application very easily. All right, these are the two benefits of trpc. This is why it's very popular, not very popular, very nichely popular, but is used in big good projects. All good projects sort of starting to adopt it, so it's good for you to understand. All right, now let's dive deeper into some concepts by going into the trpc official documentation. So this is their concepts page, which gives you a very high level abstract idea of what trpc is and why it's used. Let's start reading it. So as I said, trpc mein the thing to focus on is rpc, which stands for remote procedure call. What is RPC? What mindset should I adopt when I'm trying to use trpc and writing my backends in it? RPC, it's just a function. RPC is short for remote procedure call. It is a way of calling functions on one computer from another computer. Again, under the hood, uses HTTP or whatever, but you as the application developer, it feels like you're simply calling a function on your machine only, but under the hood, it is making a call somehow to a server somewhere else, communicating with it, getting back a response and showing it to you. With the traditional HTTP/REST APIs, the things that we've used until now, you call a URL, you get a body, you give headers, you get back a response. With RPC, you call a function and you get a response. That's the high level difference between both these things. So this is how we have done things until now, where on our React code, this is how we send fetch requests to get data. This is how we'll be doing things now that we have trpc. You'll simply be calling how you'll get this API function or like some high level variable, and you can simply do api.users.get user by ID or get by ID, send your arguments and you're good to go, versus writing this code, understanding what is fetch, what is the kind of request that you need to send, so on and so forth. All right. Don't think about HTTP REST implementation details. Whenever you're using trpc or any RPC library, don't worry about how is the communication happening. You can still open the network tab and look. Whenever you do an RPC call, you can still see requests going out. You don't have to look at them. You just have to feel this function is being called on my machine, even though it is being called remotely, hence the word remote procedure call. All right, now there is some vocabulary. This is specific to trpc. Every library has its own. You have to understand maybe just 3 things for now, and maybe router. So 4 things, and then we will get to context and middleware later on. Let's start with the first one, procedure. A procedure is an API endpoint. Basically, it tells this is one function that my end users can run. So get user by ID, create to do, delete to do. Each one of these is a procedure. Procedures can be of two types, either a query or a mutation. अब ये इनके दिमाग में था. It is in their head कि they created two. They could have created five. They could have created one. You can just suffice with query. You can just suffice with mutation. But just like in HTTP servers, it is a good practice कि if you are changing data, you send a post request. If you are updating data, if you are adding data, you send a post request. If you are updating data, you send a put request. If you are getting data, you send a get request. Similarly in TRPC, it is a good practice if you want to get data from the server, a procedure that gets some data, you create what's called a query. We will see how you create that, but from an abstract level, if your end user wants to get some data, for example, they want to get all of their to-dos in a to-do application, you will create a query on the backend. If they want to update data, which means they want to add a new to-do, you will create a mutation on the backend. What these mean, we will come to very soon, but these are two terms that you need to know. You either, just like in HTTP servers, you create either a get request or a post request or a put request. In RPC, specifically TRPC, you either create a query or you create a mutation. These are the two high level procedures that you can create, either a query or a procedure or a mutation. What does that mean? If you want to get data, you create a query. If you want to delete data, update data, add data, then you use mutations. All right. Lastly, there's this thing called router, which is a collection of procedures. This is similar to the app variable in Express. So if I go back a slide, this app variable is like a router where you say app.get on this endpoint, do this. App.post on this endpoint, do this. Similarly, TRPC has a router. Okay. There are 5 procedures, combine them together and put them in the top level router variable. So that's what a router is. What are the 3 things or 4 things we understood? Specifically just 3 things. A query, a mutation and a router. What is a router? It is similar to the app variable in Express. What is a query? Anytime you're writing app.get in Express, you will create a similar corresponding query in TRPC. What is a mutation? Anytime you're writing app.put, app.post in Express, you will create a corresponding mutation in TRPC. That's a high level. And if you look at the code difference between the two, it's something like this. Don't worry about this syntax too much right now. Just at a high level, try to understand what's happening. App.get/todo. Let's say there's a get endpoint that you've created. Ideally, it should be post because you're getting the title and description from the end user. You're putting it in the database and you're returning back some data to the user, or like the title, the description, and let's say a dummy ID for now. The equivalent of this in TRPC looks something like this. Now, don't worry too much about the syntax. From a very high level right now, you get a router variable from somewhere, just like you get an app variable here, you define it above. We will get this router variable somewhere from above from TRPC. Inside the router, if you remember from these docs, it says a router is a collection of procedures. I have defined one procedure here, the to-do create procedure, which is similar to, in the HTTP world, a post endpoint that lets you create a to-do. The to-do create procedure expects what kind of input, so you have to be very strict in TRPC and give the input upfront. You can use Zod for it. Again, if you don't know Zod yet, don't worry about it. We will sort of understand this a little bit better when we start to code. But you have to define the input very strictly, versus here, if you look at it, we never really said ki the input needs to be strictly this. You can do a Zod check here, which is the same as what TRPC does for you here. Okay. The input for this needs to be title, which is a string, and description, which is a string. And then finally dot query, which is similar to dot get here, because we're sending a get endpoint, like trying to get data from the server while we're trying to post data here. So ideally this should be dot post and this should be dot mutation, but assuming this was the endpoint to get data, then this would be dot get and this would be dot query. Since this is an endpoint to actually put data on the server, this should be dot post and this should be dot mutation. That's the only difference. And then here you define all of your logic to do all these things. And this is how you can extract the input from the user. And this is how you used to get it in the HTTP server. So just look at this for maybe a minute, both the code on the left and the right. Look at the differences. Let me do a quick recap and then we will proceed and starting to code. What's the recap? We are learning about a new library called Trpc. It gives us a bunch of benefits. What? Don't worry about it. It gives you benefits. It's a new way to write backend systems. How do you write a backend system in Trpc and how is it different from how we've been writing it in Express? If this is an Express endpoint, to assume this was post here. So if this is an Express endpoint to post a to-do on the server, you get the input from the user like this. You do some database stuff, which is you put the specific to-do in Mongo, in Prism, using Prisma in SQL, so on and so forth. And you return to the user the title, the description, done, false, and some ID. You can also get the ID from the database here. What is the equivalent in Trpc? It is create a router. So this router variable is similar to the app variable. The dot get is similar to the dot query here. If this was a dot post, this would be a dot mutation. And the to-do create name is similar to an identifier for this specific route. So whatever you name this is the function that the end user will call on the client. If you don't understand this, that's fine. Don't worry about it. We will see this very soon. Inputs need to be very well defined here in Trpc. Ki haan bhai, this is the input that this function expects, which in this case is an object which has a title and a description. Both of these are strings. And then the body is basically the same. This is how you extract the input from in a Trpc backend. This is how we've been extracting inputs in our archaic Express backends. All right. So go through, look at both of these things, take 30 more seconds, and then we will do a poll. And based on the results, we will proceed. One thing that we've not covered yet is how these functions get called on the front end. For this, you just do a fetch call. We will see how a client is generated for this, and you can do remote procedure calls on the client, but we will come to that once we start coding. All right, let's do a poll. %. I was very strict. Okay, we will only proceed at 85. So would love to know from the 20% what's up and which part seems a little weird. What is public procedure? This thing I will explain very soon when we get into the coding a bit. This is basically, as you remember here, you have to create procedures, and this is one way to sort of create it. How you get this public procedures variable, we will get to very soon. That is a good question. Where does the Z come from in Trpc? So Z is the Zord library that we've been using until now. So this is an external library that lets you do input validation. We have done this in the past when we were discussing Zord a few weeks ago. And you don't necessarily have to just use Zord. You can use a different input validation library. Trpc supports a bunch of these. The one that we used, or the one that we're using in this specific tutorial, is Zord, but this is an independent library. That's where the Z variable comes from. When we start to code, you will sort of bring it locally on your machine and see what library it is and what it does. Is a Python wrapper to any API example of RPC? I don't understand what a Python wrapper is, so I wouldn't comment on that. Let me open SAT again. Is any, for the 20%, the main idea of HTTP protocol was to maintain a standard. Doesn't this deviate from that? So this is also standard, right? RPCs are also a standard. Okay, you do remote procedure calls, you define functions somewhere, and then another person calls it. So this does deviate from it, but there are benefits to it. It gives you automatic types on the client, which is something we will see very soon. Some people like it, some people hate it, but yeah, this is something that's being used. So, but I do agree, okay, HTTP is a standard, but like you could argue that RPC is also a standard. So under the hood, this converts the code into required Express or Next.js equivalent. Sort of, yes. You write this code and then you tell it ki haan bhai, you convert it to Express or you convert it to whatever. Next.js, and this converts it into that code, and then you start that specific backend server or Next.js server based on what conversion library you use or what adapter you use, the thing that we discussed here. There are a few adapters that they have. Based on which adapter you finally end up choosing, this gets converted into that sort of code and you run it. What is the dot input equivalent in Express? Repeat the dot input thing. Yes. So in Express, there is no need for you to very strictly define कि हाँ भाई, this needs to be my input type. You can, and when you do that, you use something called Zod. So if you might remember from, if I try to go a few weeks ago, I don't remember which week exactly, so I'll try to keep this short if I can find it. Great, if not, okay, never mind. So there is no exact equivalent in Express. In Express, you don't have to do input validation, but it is a good idea to do it because your end user can send you any data. The title could be very long. This could be have some, let's say, weird terms that you don't want. This could be 500 letters and you don't want an end user to be able to send 500 letters. This could be a number. This could be an object. You need to do what's called input validation. The library that we have used in the past to do input validation is called Zod. And over here is where we would do a check. Okay, we would do z.safeparse or like the Zod type.safeparse and make sure that haan bhai, this rec.body follows a certain pattern. This is the equivalent over here. This z.object we have created in the past in Express and we have done validations here. This z library is the same as the z library we have used here, and here we had to do a manual check here कि हाँ z.safeparse make sure that the rec.body follows this specific pattern कि there is a title and description and both are strings. In TRPC, this is how you do it. So that's the equivalent of input validation here. And why you need it in TRPC is because you need to very strictly say कि हाँ this is my input for this specific procedure or the specific to do create function, so that whenever you automatically generate the client knows कि हाँ these are the inputs I need to send. Whenever you're trying to do this remote procedure call, where did it go? So whenever you're trying to call a function on the other side, you know the arguments that you need to send because they have been clearly defined here. Versus if you look at Express, we never really clearly defined कि हाँ this to do expects these inputs. When we converted into the OpenAPI spec, we sort of little bit saw okay, how you can tell the end user what inputs they need to send. But generally when you're creating an Express backend, your end user can send you anything, right? Unless you do an actual validation here, a zod.parse, make sure that the title is a string, description is a string. The end user can send you anomalous data, which could sort of mess up with your database. If they send a very big object here, that will create issues in your database. But if you use TRPC, it will validate कि हाँ भाई, title should be string, description should be string. Only then will the control reach here. Else the control will sort of, the project itself won't compile, and we will see that very soon. And that's because this creates a client for you automatically. If you send the wrong data there, the front-end client will sort of complain and not compile. Your code will not compile, and you won't be able to send that RNS call. If you are able to somehow send that RNS call, Zod will make sure the control does not reach here. TRPC will make sure that the control does not reach here. All the validation checks will be done. But there is no equivalent of this in Express unless you're doing explicit Zod validation at this point somewhere. All right. Good question. Let's do a quick poll again. All right, good to go. 91%, which is great. Let's start to write a code, some code. Let's create a basic to-do application server and client. And we won't really be writing the client in a browser. So we won't be writing a React application. We will sort of be writing a Node.js backend only that is able to make remote procedure calls. You can use that backend as such in your React application, your Next.js application. Your Next.js application will also be able to make the same calls. But today, for today's class, just to make sure we're not getting into front-end code too much today, we'll write our front-end in it's sort of in Node.js only, which might sound weird. Okay, how are we writing front-end in Node.js? And the answer is we're writing a client. A client could be a Node.js client. It could be Postman, it could be what do you call it? React app, it could be a Next app. A client is just someone who either sends an HTTP call to a backend server, or in our case, does a remote procedure call. A client could be anything. It could be Postman. It won't be Postman in case of RPC, but it is Postman when you're sending HTTP requests. It could be a mobile app. It could be a native app. It could be Node.js. It could be whatever. In our case today, it is going to be Node.js. So backend is going to send RPC calls to another backend. All right. Even though it is a backend, it is still called a client because it's what's calling the thing on the other side. All right. Cool. The way we're going to do this is initialize an empty project, and we'll go through their quick start and sort of build upon it and create our own use case, which is creating a to-do application. What are the endpoints that we need? Create a to-do and then maybe update a to-do. 2 endpoints we need. And we will do authentication later on. So don't worry about users yet. Just let anyone do a remote procedure call and put a to-do in a database. Then let them update the to-do by sending an ID. These are the 2 procedures we need to create. What was the equivalent in Express? We would have had to create 2 endpoints. Today we're creating 2 procedures. All right. Please initialize an empty repo. I am going to do the same. Would urge you to run this locally, or you can just follow along. So I'm going to create a new directory, call it week 14.1. I'm going to open it in Visual Studio Code. All right. I have an empty project open here. Going to give you guys 10 seconds to do it yourself in case you're wanting to follow along. Cool. Let's initialize an empty package.json here. So npm init-y will create a package.json file here. Let's create our tsconfig file, which is tsc-init or npx tsc-init. This will create a TypeScript tsconfig.json file. Package.json is this thing right here. Maybe one thing you can do is create an out dir here and make it ./dist, so that your JavaScript code that's finally created from your TypeScript code is put in a new folder, the dist folder, and sort of cleaner and separate from the TypeScript code. So would urge you to do 3 things. Thing number 1, npm init-y, make sure you're running it in this folder. tsc-init or npx tsc-init to create tsconfig. And number 3, change this out dir to be ./dist. All right. Cool. Let's look at what's the next thing it tells you. It says install these 2 libraries. So trpc exposes 2 high-level libraries that we are using right now. It exposes a bunch of others, but these are the 2 important ones. At trpc/server, at trpc/client. Right now, we're putting all the code in the same, call it monorepo. It's not exactly a monorepo, but yes, a single folder which is going to have a server folder and a client folder is how we're sort of doing things today. You can convert this very simply to a monorepo. Cal.com does that. You can create a package for the server, package for the backend, so on and so forth. For now, we're keeping things simple. We have a single folder. In this single folder, I'm going to create a server folder and I'm going to create a client folder. So this is what my folder structure looks like finally. I have an empty client folder, an empty server folder, and a top level package.json, a top level tsconfig.json. All right. I have installed these 2 libraries. Hopefully you have as well. Now let's look at the things that I've written here in the slides. There are 3 steps usually to writing a backend in trpc. Step 1, initializing trpc. Step 2, defining your router. Step 3, using the adapter to serve the API. This is the smallest basic boilerplate code you need to write. Let's start with step 1 and then we'll move to step 2, where you actually write application specific logic, which in our case is going to be to do app specific logic. Before we do that, let's initialize trpc. The way to do that is They've already told you this. In server/trpc.ts, put all of this code. We'll try to go through each one of these very soon. So in your server folder, create a new trpc.ts file and paste all of this code. Let's try to look at what the code does. We call init trpc.create. This returns a T object, or whatever you want to call it. You can call it trpc. Just general practice is to use it, call it T, similar to how general practice in Zod is to call it global variable Z. Then we export two things from here. This is again general practice. You don't have to create a new trpc.ts file, but the general practice is, as it says, first let's initialize trpc backend. It is a good convention to do this in a separate file, which is trpc.ts, and export reusable helper functions instead of the complete trpc object, which means you could have simply exported T from here. Export const T equal to init trpc.create, but generally you don't want to export the full object. You want to expose just two things. A few more things later on, but right now just two things: a router and what's called a procedure. So someone who was asking what is the public procedure, where does this public procedure comes from? The answer is this file. The router variable, the public procedure variable, both come from this file, the trpc.ts file, where you define these global variables and export them. The router, which is similar to the app variable if you were using Express, and public procedure, which is a top level procedure, not really a procedure. It lets you create other procedures. It is a variable that lets you create other procedures. For example, here is a to do create procedure that we had created, which was a query, could be a mutation. But the public procedure variable, this variable right here, lets you create a bunch of these queries and mutations. So these are the two objects that we export right now. Router, which is similar to app, public procedure, which is similar to, well, not really similar to anything, but maybe similar to nothing. Not at all similar to anything in the Express world, but this is what lets you create procedures. These are the two variables that you need to worry about right now. Itna part clear? And also, are you able to reach here? I'm going very slow, at least until the first bit, until we have written our first one or two endpoints, and then we can increase the speed. All right. 86%, pretty good. Hopefully you guys are able to follow along. Let me remove these comments so it looks slightly cleaner. Initialize, export these two. Now, what's the next thing it asks you to do? It says create an index.ts file, which is where we will define all of our procedures. So let's create an index.ts file. Import a router from ./trpc. Then write all of your code, which we had written in the last slide. And then do one more thing at the very bottom. Export type app router equal to something. Let's look at all these three things one by one. The first thing it does is imports the router variable from this trpc.ts file. Again, in the Express world, this would have been export const app equal to express. And then in index.ts, we would have imported it and done an app.get here. Since this is trpc, what is the variable that is export? The variable that is exported is router. How do you use it on the other side? You create a top level app router. Inside is where you define your procedures. The first procedure we want to define is, let's call it create to do. And how do you define a procedure? Let's scroll down a little. Create to do is public procedure. Where does public procedure come from? Again comes from trpc. Dot input. What should the input for a public procedure be? Specifically a create to do app be? It should have a title and a description. That's what the end user should send you. That is what you will define here. Before you do that, you need to add an input validation library to your code. There are many, and trpc also supports many. The one that we have been using and we will use today is Zod. So in your terminal, before you proceed from here, please run npm install Zod. So you can get Zod, the library, into your code base. And this is where the Z variable comes from for whoever was asking. So these guys basically have no input here, but we want input. So let's move to the third point here and see what it says. import Z from Zod. So this is how we've imported Zod in the past, and this is how we have created types in the past. For example, const to do input type equal to Z dot object, title Z dot string, description Z dot string. We have done this in the past when we were doing input validation in Express. To do the same thing in trpc, you can either define this object outside and pass this in as an input, or you can just take this whole object and paste it here. This looks slightly cleaner, so I'm going to keep it like this. And we have defined what is the input that's expected for this procedure. Finally, we have to define the body. The way to do that is this a query or is this the mutation? The answer is, since the user wants to update some data, post some data, this will be a mutation. Again, you could totally just write query here. It will just work for similar to how you can simply send post requests and do everything. But what's the general practice? When you want to put some data, you send a post request. When you want to get some data, you send a get request, so on and so forth. So this is just standard practice for you to use the right thing between mutation and query. In this case, we're using mutation because mutation is what is standard practice to follow if you're trying to mutate data on the server, which in this case we are trying to create a to-do on the server. All right, here you define a variable, a function. Let's see. Yeah, function. This might feel a little weird to people who have not done callback function in the past, which is you send a function as an input to a function. We've done this many times now, so hopefully this isn't too difficult. And this is where you get access to everything. If you want to know the title, you do const title equal to ops dot input dot. Notice I get very nice type safety here. I press dot, it tells me there's a description variable, there's a title variable. This is one of the benefits of using trpc, and we'll see this very soon on the front end client as well. But right now, it gives me very nice sort of code completion, which is something you don't get in this world. In the Express world, you never know. rec.body. Does not give you auto completed title or description. trpc does, because it's able to figure out कि हाँ, input type looks something like this. Hence, ops.input.title should exist, and similarly, description should exist as well. We get the title, we get the description. Do db stuff here. We're not doing that yet, but we can. And finally, return. So rather than doing res.json or whatever, you can simply return. In this case, let's just return ID1, and maybe that's it. Maybe let's just return the ID of the new to-do that was created. Maybe let's make it a string, because we'll be using MongoDB eventually. MongoDB does return a string ID. So let's return that here. And let's try to go through the whole thing again one more time. And I would urge you to maybe cope up first, reach this point, and then we'll proceed. A quick recap is, this is how you create an equivalent of an HTTP endpoint in trpc. You get the router variable from where? From the file that we defined. And here you say, acha, the first endpoint of mine, or the first function of mine has this input. It's called create to do. The input that it expects is this, a title and a description. It is a mutation. And this is the logic that should run whenever someone does an RPC call. Whenever a browser does an RPC call, another server does an RPC call, a mobile app does an RPC call, this is the code that should run. And this is how you create your very first sort of function, and not endpoint, but equivalent of an endpoint in an Express server. We have not yet exposed it via Express. We have not yet used adapters. We have just defined a router. This is the one thing you need to define always. And then converting it into an HTTP server, creating an HTTP server out of it using Express Next.js is the third step that we will cover. Before that, is this part clear as to how you can create an endpoint of your own? Very good. Okay, cool. So let's proceed. Lastly, one important thing to know is this thing that's been exported. The only thing that this index.ts file exports is this type called app router, which uses the type of variable and app router. So type of basically lets you, for example, if I write let x equal to 1, 2, 3, what would type of x be? If I hover over it, it will be a string. It gets the type of the specific object. If I make let x equal to title 123, now if I hover over it, what is the type of this x variable? Maybe let's make this y. It is an object which has a title which is string. So that's what type of does. What are we getting the type of? We're getting the type of app router. How is it created? Trpc creates it. If I hover over it, what does it look like? Some bunch of things we see here. Important thing is there's a create to do. Somehow this app router type has this create to do procedure. Why is this useful? It is useful on the client. So let's quickly create the client, which again, for now, even though it is Node.js application, the client could be a React app, could be a Next.js app, so on and so forth. For now, it's just another backend server or another sort of index.js file. Before we do that, serving the API. Now that we have defined our router, we can serve it. This is where adapters come into the picture. Do you want to use Express? Do you want to use this standalone, which I think is their own implementation of an HTTP server? Or do you want to use Express or Next.js, so on and so forth? This is the third part in this slide right here. We have initialized trpc in the trpc.ts file. We have defined one router which has one procedure, the create to do procedure. Step 3 is serving it using whatever adapter you want. Since we're not using Express right now, not using anything else, we will use the standard standalone router. So copy the first line, paste it here. And lastly, copy the last 2 lines and then paste them either above the export or below it. And you're good to go. Your backend server is done. Your backend server will run on a port 3000. Again, it is an RPC call. Under the hood is using HTTP, but you have to think of it as an RPC call, which means a function being called remotely on a server. Our backend is complete. Now let's look at what the front end code would look like. This is the complete backend code. If you want to look at it, there is well, this is too much. This is the server db.ts file. Let's not get there. This is the code in case you want to follow along and reach here. It's a little too much for one page, but let me try to put it in one page as much as I can. This is all the code for our backend server. Feel free to take a screenshot, marinate, whatever. From here, it's just creating more and more functions. The only thing that's left is how can you call this on the client? So let's do that next and then we'll take a break. Setting up the trpc client. Again, the term that's used is client, but the client can be in a Node.js application. One Node.js application can call another Node.js application, just like one mobile app can call something on a backend server. How will we do it? We created a client folder. Inside, we're going to create an index.ts file. So let me do that. Would urge you to do the same. Create an index.ts file here. Maybe copy the whole thing and then we'll try to understand what's happening here. So at the top, it says import create trpc proxy client and HTTP batch link from this library, the add trpc/client library. This is the library that you will use in React, in Next.js. It will work everywhere. We are currently using it on a backend server. It exposes 2 variables. What these do, we will see very soon. Finally, it says import type app router from /server. So firstly, make sure you change this to /server because our client and server folders are separate. So from this index.ts, if you want to reach this index.ts file, you will have to go one folder above and then go into server. And then you can also write server/index, or you can simply write server. Both are the same thing. Where is this app router defined? We just exported it from the index.ts file. This export type app router is what we're trying to import. And this has all the structure of your procedures. It is this variable that generates the client here automatically. This you can assume is similar to the OpenAPI file. This has all the types for your router. So it on the client lets you sort of do things like this trpc dot. It automatically gives you the create to do procedure because it knows that trpc object has a create to do method on the server. How does it know? Through this app router variable, because this is exported from where? This is exported from here. export type app router equal to type of app router, and this small a app router is which has one procedure right now. If I add another procedure here, I will see that here. So this is the high level pitch of TRPC. It gives you automatic types on backend and front end. You just define your backend route like this. You export the app router variable. You import it on the other side. You pass it to the create TRPC proxy client method. And then if you do a TRPC dot something, it will automatically give you type completion. In fact, if I do a create to do, if I type title here, or maybe it's something else, let's see. Querying, dot mutate, correct. If I do trpc dot create to do dot, it gives me a mutate function. If I do call this, it will also tell me what is the input, title, string, description, string. If I go here and if I change this and add a done variable, which is z dot boolean, I just made this one change. I have not compiled anything. I did nothing else. I go back here. I hover over it. I see what? I see title, description. I also see a done variable. If I make the done variable optional using Zod dot optional, I make no compilation changes, nothing I change. I hover over it. I see done becomes optional. I see a question mark here. So this is the high level pitch of TRPC. Automatic types on front end and back end. So your application never breaks. Because a lot of times what happens in the real world is you create a backend server, the shape of the backend server changes a bit, your client never updates, and then you're sending the wrong API calls. Let's say in an Express server, you had a post call to /todo, which changed to whatever, /todo /create. Your client would never know this, they need to make this change. TRPC will change the types everywhere throughout your code base, in your front end, in your various clients that you've written in your monorepo, and your compilation will begin to fail unless you actually fix the thing. Which in our case, let's say is add title, go to gym, add a description, hit the gym, and then done was optional. Let me just remove it. So let me go back here and remove done. Let's just accept title and description as an input, and you can do a trpc dot create to do dot mutate. All right. This is an asynchronous function, so I would urge you to put this inside an async function. Let's create an async function, call it main, and put this logic inside here, and then simply call await on this and call main. You can also do let response equal to await of this thing, and then if I hover over response, what do you think I should get? ID string. TRPC was able to figure this out as well. Okay, what is this guy returning? It is returning an ID, which is a string. If I add some new thing here, let's say description, something random. If I go here and hover over response, I see description as well as ID. So that's how automatic type generation happens in TRPC, both for the inputs, these things, and the outputs. And I can just log response here maybe. Again, right now this is a backend application or like an index.ts file. You can put this in a React application, it will just work. All right. Now, lastly, we need to run this. So let's see how you can start your backend and start this client that can interact with the backend. Firstly, tsc-b, which is compile the code, and you have a dist folder which has a client and a server folder. Node dist /server /index.js to start the backend or start your RPC server, and then in another terminal, node dist /client /index.js, which ignore these warnings, sends a RPC call, which under the hood, as you can see from the warning, does send a fetch call only, and then returns you ID1 from the server. If I go back to the server, if I add some logs here, let's say console.log hi there, you will see that thing logged here if I recompile the code. Run the client again, and I see hi there. Every time the client does a call, I see hi there logged, which means control is indeed reaching here. And all you had to do was this, rather than doing let response equal to fetch localhost :3000. Or what was the method? Such a method was post. Or what is the body look like? oh, let me go here and figure out the body. Here you get automatic types. Here you would have had to go there, and the response you would get would have an any type. So you don't really know the types of the response if you're sending a fetch request. Versus if you're using TRPC, there are types everywhere. This guy has a type. This mutate function has a type. Everything is the auto completion. That's the high level pitch of why TRPC is good. All right, let's do a poll and understand where we are at before we proceed further. %80 is great, not bad. We will still take a pause here. So break for 80% people, 20% people create no break. We'll be back in 10 minutes. So I'll see you guys at 8:15. The 10% folks, people who are still facing doubts, or 20%, what's up? Tell me. Okay, let's do a pause. What if our client and server are not in a monorepo? If your client and server are not in a monorepo, they will need to be in a monorepo because this router type needs to be imported from somewhere. If they're not in a monorepo, you could still have the backend publish this app router type on like an npm registry, and you can get it from there. Usually frontends and backends are, if you're using TRPC frontend and backend, they will reside in the same repo, and you won't really have the backend in a separate repo, frontend in a separate repo. It can work there as well, but probably a lot of benefits go away, because the biggest benefit of this is ki I made a change in the server, I immediately see an error in the front end. That is the benefit, and that benefit only comes if they reside right next to each other. So usually you'll see TRPC being used in monorepos. I don't think there's any use for TRPC being used in like a non-monorepo environment. What is the client? Okay, that's answered. Does all the functions will be defined in a single page? No, you can. I'm assuming you mean, do I have to define all the functions here? No, you can actually like create different routers. You can finally merge the routers. You can do very nice project file structuring. We're not doing that right now, but yes, you can create one router, you can create another router, and then you can finally merge routers and then merge things from two different files, so on and so forth. So how to write endpoints like get to do or update to do? So get to do will simply be, we'll get to this very soon, but something like this, get to do. Does the get to do endpoint need to have any arguments? No, it doesn't need to have any input. Is it a mutation or a query? It is a query because you're trying to get data. And here you will just, send your database call and then return an array of whatever, ID, description, title, so on and so forth. So that's how you do a get to do, although we will discuss this very soon as we proceed. TRPC nested routes. I will have to check what that is. I'm assuming that is something that lets you merge routes together. I could be wrong. Probably something else. Let me Google this really quickly. That is not something we wanted to cover today. Do you mean merging routers only, or do you mean something else? Is Notion library in Python, which basically sends calls to Notion HTTP API? So this is an example of an RPC call. No. So that is a HTTP call, and there is, as you said, a Python library which is also called a client that gives you functions. That's not technically an RPC call. That's what's called a client, a Python client that has been created that under the hood also sends an HTTP call. But RPC is a protocol in itself, and not exactly protocol under the hood. It is using HTTP. But the thing that you're mentioning is the thing that we have done in the past when we discussed OpenAPI, which is your backend is an HTTP server. You create an OpenAPI file, you generate clients for it, which in your case is a Python client. In our case, we generated a Node.js client. Then you're still under the hood doing an HTTP call. You can still call it a remote procedure call, but technically the function isn't defined as such on the Python server. So you may or may not call it an RPC call. Most probably I would not call it an RPC call if it was an interview question. Where is the adapter which is converting it? This thing right here, sir. The create HTTP server comes from @trpc server adapter /standalone. Similarly, there's a next adapter. There is an express adapter. Each have their own sort of syntax. This is the one that we've used, which is their standalone adapter, which I think is their native adapter that they've written themselves. Could be wrong. Maybe it uses some other HTTP server. How is authentication done in TRPC? Header information, etc. Good question. Something we'll discuss very soon. So backend is vanilla Node. Yeah, it is Node.js in TypeScript. Main idea. Okay, I think I answered that. Any more questions? what is Codium AI in your this thing? So it is an alternate to this thing. I haven't yet started it. I installed it and it broke my VS Code for some reason, but yeah, I saw it somewhere. It's pretty cool, so I installed it. Haven't used it yet. What is the difference between GraphQL and TRPC? Like, can we get specific data in TRPC like GraphQL? So you cannot get specific data in TRPC like you can in GraphQL, even though the terms seem very similar, and TRPC is sort of inspired from GraphQL when it comes to these terms, query and mutation. But I'm pretty sure you cannot do selective. It is an RPC, which is different from the GraphQL protocol. What is an RPC? There is a function, you call it and you get back data, and you get back all the data, you send all the arguments. Versus in GraphQL, you can selectively select data. GraphQL is better than TRPC except for the code gen. Can we get specific data in TRPC? And is GraphQL better of TRPC except of the code gen? I don't know which one's better. Both do almost a similar thing. GraphQL is slightly better, can let you selectively get data from the backend. But again, it depends on the project, right? Whatever the maintainer of the project used, you use. If I were to do a project today, I'm pretty fascinated by TRPC. I would probably use it. But yeah, it really depends on the maintainer. Please show how to run the client and the server again. Sure. So first thing you have to do is compile your TypeScript code into JavaScript code. So you might not be seeing this dist folder locally. If you run tsc -b, assuming you have done npm i-g tsc in the past, which means you have tsc as a global variable, the TypeScript compiler. Then if you run tsc-b, a dist folder is created which has your TypeScript files converted to JavaScript. Then the way to start the server is node dist server index.js. This will start your RPC server. And then in another terminal, you can send node dist client/index.js, which will send your RPC call. So basically, to run the backend on our front end, we just need app router type. So basically, okay. We are not running the backend on our front end. The backend is still running somewhere else. This is the backend. It is still running on some AWS server somewhere. This is the if this is the front end, it is running here. It feels like you're doing a procedure call here and the backend is sort of being called on the front end, but that is not happening. It is still sending a request, a network request. There is some computation that's happening here. You're getting back a response. It's very well abstracted from you. So it feels like you are doing, where is it? It feels like you are doing a simple function call here or a procedure call, but as the name suggests, it is a remote procedure call, which means there is a request going somewhere and that backend is running the code and it's coming back. /server is the same as /server index.ts. Is this behavior of JavaScript? Yeah, you can /server, if there is no server.ts file here, then it will just look at the server folder and try to find the index file there. Only there's an index file here does this work. If it has an app file here, it won't work. But if server.ts does not exist, then it will look for the server folder and find an index.ts file here. Does it handle CORS? That is a good question. I don't know. That's a good question. Probably you'll need some sort of an adapter here to handle CORS. That's a good question. The good thing is we'll be running this in Next, and Cal.com runs it in Next, in which case the front end and back end are on the same port and the same URL, so you don't have to worry about CORS. Okay, I think I showed this. I was talking about merging routes, right? Yeah, exactly. How do we do dynamic routing in TRPC? So why do you need a dynamic route? It is when you expect the user to give you some arguments. App.get. In Express, we used to do app.get /users/ I don't know, :ID. And this was the dynamic argument. In TRPC, you would create a query which, or like the input would be a z.string, which is this ID right here. So you don't need to do dynamic routes. The dynamic route in Express can simply be an argument here basically. And you create a user's procedure and then the input is the dynamic route that you were talking about. So yeah, basically you can do dynamic routes in this thing. Only it's like a static route which has one more argument, which is the dynamic route that you are sending in Express. Can we add client code in React code, or is it page specific, or do we have to create another folder for this in the React directory? In your React code, in any file, you can at the top import basically write function like this. Ideally, you should create this in your React application, create a new file called whatever client.ts, and from there just export this trpc variable and then use this all across in whatever component of yours. So if you're using this in React, just use this much code, export this trpc variable, and then use this trpc variable wherever you want. All right. We're at 8:15. Let me do a quick poll here. Right. 85%, which is great. So 15%. Don't, as I said, this is an advanced class. You need to know this, especially if you want to go through the cal.com code base. Even if you don't know this, your merge stack journey is still like technically fine. You still know the merge stack, whatever. But I would urge you to come back to this video after the class and choose some class. But 85% is great. So let's proceed. Now we understood how to write one endpoint. Let's quickly cover how can you do authentication. Basically, how can you send headers, things like these. Again, it will be a little different in Next.js when we'll be using next auth, so on and so forth. Today we'll be doing the standard authentication using headers like we've done in the past. Let's see how you can do that. And then we will move on to some advanced concepts. So this is a big checkpoint. Okay, you can create your own TRPC server. You understand the server, you understand the client. 85% is great. From now, there are some things, these are like very small things you can do on your own, but let's maybe cover them. This, and then contexts and middleware, which is the advanced thing I want to cover. There's a good chance this probably will happen tomorrow. Today, at least we will cover how can you do authentication and what are these output validators, and this is something simple. All right, let's begin with how can you do authentication in your to-do application. So firstly, for that, you will need to create a users table. Let's do that. Let's create a users procedure here. There's a create to do procedure. What should a user's procedure look like? Let's create a sign up procedure. Let's say user sign up. Public procedure dot input. What should input be for a sign up endpoint or a sign up this thing? It should be an object which has two keys, a username or whatever, an email which is a z.string, and a password which is a z.string. Will this be a query or a mutation? It will be a mutation. Opts, which stands for options. Let email equal to opts.input.email. Password equal to ops.input.password. Two database stuff here. What will you do next? You will create the token for the end user. So gwt.sign. Let's see. First, you have to install the JWT library. Let's say you already have that defined somewhere. Let's also take that as a black box. Let token equal to, let's generate a random token 123, and then return token. All right. Again, actually, you have to sign using JWT sign, so on and so forth, and then return the right thing. I'm just going to return a random token here for now. So we have created a sign up endpoint where the user will send an email and a password. You will do validations here. Okay, this user already exists or not. Maybe this email is already taken, so on and so forth. After you do the validations, you will put their entry in the database. After you've done that, you create a token using JWT, that library, and then finally return the token. The user gets that token. Let's try to quickly see this sign up endpoint works or not. Go back to client/index.ts. trpc.signup.mutate email, and then password. As you can see, very nice red squigglies it gives me if I'm sending the wrong inputs. I get the response. Let's log the response. Let's rebuild the application. Let's restart the backend server. Let's let's send the client request again. And I get back a token 123. What are the changes that I made? I created a new procedure called sign up. Public procedure dot what is the input? Expects an email and a password. It is a mutation. Gets the email and the password. You do whatever you want with it, your database manipulations. You get the token and then you finally return the token to the end user. How do you get this? Using GWT, the library that we've used in the past. Now that you have the token here, how can you send it in every request that you're sending out? That is the question. And how do you do validation here? Okay, the user has sent a header. How do you validate whether or not they've sent the right header? This is where two things come into the picture. Contexts and middleware. Ye simple hai. I will cover this. Nothing too difficult here. Contexts and middleware is very important. Very important for many languages. Middleware we've done many times. Ye context is also a very popular, very important thing to know, used across languages, and will overwhelm you ki haan bhai, how did this happen or where did this come from? So there's something you need to know. Let's spend some time on context today. We can do middlewares tomorrow. If we get to them today, great. All right. What have we done until now? Ignore the to-do endpoint completely. I'm just going to remove it. I have a sign up endpoint that returns a token to the end user. Now that the user has a token in this response dot token variable, one, how can they send it in the header? Two, how do you do authentication here so that if I have another endpoint here, which is, let's say, I don't know, create to do only, how can I make sure create to do only runs for people who have signed up or who are sending the right header in every RPC call that they're making? All right. For this, you need two things, middlewares and context. For specifically this, you just need context and you'll be good to go. Let's understand what that is. What the fuck is context? Very important, very popular, used in a bunch of languages. Advanced usage. When you initialize your router, Trpc allows you to set up request contexts. What is that? Assign metadata to procedures, format and handle errors, transform data as needed, customize your runtime configuration. Too many things. The one thing that we need to focus on is you can use method. This slide doesn't look very nice. Assign metadata to procedures. Set up request contexts. Okay, yeah, the first one. Set up request contexts. So this is some advanced usage of Trpc. A bunch of things you can do. The one that we're focusing on is this. Set up request context. What does request context even mean? Whenever the user sends you a backend request, you will see this across languages in Golang, Rust. Okay? Whenever your control reaches here, your final handler, you get access to a context variable. It's called context because it is context for that specific request. What is context, Harkirat? It is usually the ID of the user or the session of the user who's calling this. In Express, the way we used to do it is we had app.get. In Express, the way we used to do it is app.get whatever /todo, auth middleware, and then rec, s. And here I was able to access rec.userid because the auth middleware would get the user's token and then put them in the request object, and then you had access to rec.userid. This was slightly ugly because the type of rec is the request object and we were putting some random key there called userid. This is why contexts are very important. Context means कि भाई anytime a request comes, it has some extra context along with the standard request parameters. It has the standard request parameters, but it also has something called the context. Usually this context is what is this specific user? What is the user's ID, email, if you want to know all of that jazz. Basically whatever happened here in the auth middleware is usually put in the context of the request. Another very important thing that's usually put in the context of the request is like the global mongoose variable or the DB variable or the Prisma variable. If you actually have to do database calls here, you can have const import mongoose from mongoose, do a mongoose.connect whatever, and then finally use this global variable here, insert or whatever. Or a lot of times it is standard procedure to send this mongoose variable also in the context of this request. This is the biggest use case of this is when you're writing tests, you can mock the mongoose variable, because when you're writing tests, you don't have to actually create the database and you want to mock the database call. For that reason, it's a good idea to always not have mongoose or your database variable as a global variable, rather have it in what's called the context of the request. Cool. So that's a high level of what context is. Let's see how you can create context in this specific thing, which is trpc, and then how we get the user's information here and provide it to this function handler in ops.ctx, this variable where ctx stands for context. All right. So whenever the request comes here, just like in Express, you would get access to two things, the rec and the res, and then using these two things, you had to pull out all the things from it you wanted to. In trpc and generally in other HTTP servers, even in Express, there's a way to do it. You get access to this context variable which holds your user's information. Maybe let's just focus on that for now. How can you put user's information here in case the user is logged in? And then we'll see how can you also like make sure this function only gets called if the user is logged in, else it does not get called. All right. So the question to answer is, how do you create a context in a trpc server? What is a context? It is basically request specific information, things like whether the user is logged in or not and a bunch of other things. But the important thing is, what is the ID of this user who's calling this? Somewhere else this should be handled and should be put in the context variable. Let's see how you do that. So let's read through this. What does it say? Your context holds the data of your trpc procedure will have access to, and it is a great place to put things like the database connections or authentication information. So the two things that they also said that you should put there: one, database connection, which is like the mongoose variable, the prisma variable, and authentication information, which means the ID of the specific user. Setting up the context is done in two steps: defining the type during initialization and then creating the runtime context for each request. It is a two-step process to create a context. It is a two-step process to create a context. Step one is during initialization, define the type of the context. Step two, during the runtime, create like the runtime context. So let's focus on step one here. What should our context be? Our context, if I have a ops.ctx variable here, what access do I need here? I need access to the user ID or the username, one of these two things. Let's say I need access to the username. So my context type should look like what? It should have a username key, which is a string. What does it say in the slides? It says defining the type during initialization. So where does initialization happen? In server/trpc.ts. During initialization, whenever you're doing init trpc.create is where you have to define just the type. This is what my context will look like. You don't have to actually write the logic to extract the context. You just have to define the type. This is what my context will look like, which in our case is something like this: username string. Now I wrote too many things, like very quickly. So let's break this down and maybe make this slightly simpler. Const t equal to init trpc dot create. This was the original thing that was written. I said it should also have a context. So I called dot context here. Okay, it will have a context as well. What is the shape of the context? Go back to our class from generics, where you can define a generic on this, which will contain the type of your context, which in our case is a username, which is a string. Ideally, it will be something like a username, which is a string, and then mongoose, which is like a MongoDB, or like prisma, which is a global prisma variable. For now, just username is all we need. Ki haan bhai, whenever a request comes, extract whether or not this user has a username or not, which means this user is logged in or not. And maybe let's make it optional, because let's say we want the context to have the username if the user is logged in, which means they've sent the right header. If they've not sent the right header, if they've not sent any header at all, then username will be empty. That's what we're going to, that's why we're going to make this optional. And this much is the syntax for step one that it told you. What was the step one? It said during initialization, define the type of your context, which in our case is the context has the username information. Question is, how do you actually extract it? And this is different for every adapter. It is different for the Next.js app adapter, different for the Express adapter. In our case, we're using their standalone adapter. And the answer here is, I think something like write a create context function here, which will sort of have access to. Now here is where I will take help of the code that I wrote before the class. Let's see, server index.ts. There you go. This is what I was looking for. Yep. So as you can see, what have I done? I had the create HTTP server. This was how we were doing things until now. Now we want, what was the step 2 in the slides? There were 2 things that were written. Define the type during initialization. We have done that. Creating the runtime context for each request. So anytime a request comes, the controls should first reach here. That's what create context does for the create HTTP server, which comes from the standalone library. If you use Next, there will be a different way to create context. If you use Express, there will be a different way to create context. The way to create context in the standalone adapter is a create context function. And as you can see, if I hover over it, it's already giving me errors. Okay, bhai, you're not returning anything. You should return a username string, but you're returning a void. So that is why it is giving me an error. If I return a username something here, the error will go away. But of course, we don't want this. We actually want to do a jwt.verify here, make sure that this auth header is correct. And then only if the auth header is correct, should we return username 123 here, else you should return username undefined because the user does not exist. All right. Let's do 2 things. Let's log the header here, just so that we know that the header is reaching here. And let's return a dummy username here, 123. Ideally, what you should do is you should do a jwt.verify here on the auth header to make sure that the auth header is correct. Only if the auth header is correct, you should return the right username, else you should return undefined. And what we'll see next is how the control first reaches here, how the context for the request is created. Once it is created, we have access to the same thing here. So now if I do const username equal to ops.ctx, if I press dot, as you can see, it has access to this key right here. It knows कि हाँ, public procedure comes from this router. And what does this router have as the context? This. That is why you can simply be like ops.ctx.username. And let's log username here. Ideally in the real world, what would you do? You would check if username exists. Only if the username exists would you create the to-do. If let's say this was a to-do endpoint, this is probably the wrong endpoint to do it. Let's create a new endpoint. A to-do or create to-do endpoint, which is public procedure dot, what should the input look like? Title. Maybe just the string. Mutation. And here let's try to log ops.context.username. So I wrote too many things together. Let me take a pause here. We had the sign up route. I have not touched this. This is as it used to be. Let me remove this logic here. I have created a new create to do route or procedure. And here I said it is a mutation. It returns something random. Let's say ID1. And here I log the ops.context.username. I don't log the header. I don't have access to the header here. I have access to the context variable. Where was the context created? It was created here in the create HTTP server. I said any incoming request should first go here. So this might sound like a middleware, even though it's not. It's what's called the context. Middleware is something else. We'll get there as well. This is something that runs before any request actually reaches the handler for it. And here is where we create the context for it. Usually the thing that you put in the context variable is 1, the authentication information, 2, things like the Prisma variable, which even if you don't for now, it's fine. You can use them as global variables defined at the top. But the authentication information is usually extracted here. You have access to the auth header. You can do your gw.verify. You can, if the verification succeeds, return the right username, else complain. Or like return undefined here. And if undefined is returned here, you can do your if else checks here. If the user does exist, then create a to-do for them, else throw an error. All right. Hopefully this part is clear. Let's quickly see how you connect it to the front end, how you can actually send a header from the front end, and then happy to do a poll and take questions. This would complete at least context, and in middlewares we can do tomorrow. Let's go to the front end code now. Client index.ts. Question is, how do you send a header? And the answer is, there is a headers variable here. I will also again cheat here and look at the syntax from the thing that I wrote before the class. There you go. So you have to define a function called headers. Sorry, define it in the wrong place here. Right next to the URL key in this HTTP batch link, you can define a function called headers, which returns whatever headers you want to send to the backend. Ideally, this would be whatever JWT that you have. I'm sending a random 123 variable for now. Ideally, in the real world, you would store the token in the local storage, and then you would get this thing from local storage.get item token, and then send that to the backend. For now, I've just hard coded it to bearer space 123, and this is good enough for you to start sending headers to the backend. How are you extracting backend headers in the backend? Let me quickly repeat. सबसे पहले the control reaches where it reaches this create context function. It gets the auth header. It does the verifications, whatever JWT verification needs to do. If it does succeed, returns the right username, else returns username undefined. Then the control reaches your specific procedure, which in our case is, let's say, the create to do procedure. And here I'm just logging ops.context.username. You might ask, Harkirat, why not do this here? Just stand practice. Okay, context holds your user information and your database information, a bunch of other things. You may also not have access to headers here. I could be wrong, but most probably you will not have access to. Maybe there is a way to do it. I don't know. But even if there is a way to get headers here, it's generally a good idea to extract that out into usually middlewares. The thing that we've done until now was we had an auth middleware that would extract this information. The way to do this in Trpc and generally also even in Express in the future, like the way to do it is actually put it in a context variable rather than the way we used to do it in Express was we would override the rec variable, which is not great. It fucks with the types. It makes typing very hard and you have to use a bunch of TSing nodes to get around it. If you did not understand this last time, don't worry about it. But this is the right way to do, get the authentication information and have the handlers have access to it, which in this case is this create to do handler. Now let's try to quickly build the code. One thing you will notice is this is extremely type safe, which means every time I'm compiling, literally there are no errors, because if there was an error somewhere, it just complains very bad and you just fix it. So this is the benefit of Trpc. As the application developer, there's very little room for you to leave mistakes like these, because it will throw it. All the types are propagated everywhere. The context type that I defined here is propagated where? Here in ops.ctx.username. So if I access whatever email here by mistake, if I'm a lousy developer, it will start to throw errors at me and you can fix them and you get very nice auto completion. Every time when I'm using Trpc, which I've started to use it very recently, every time I compile, it just compiles because it leaves no room for error, which is usually something that happens when you're writing a basic Express backend or so on and so forth. All right, compiled. Let's start the backend. Let's send the front end request. Oh, let's update the front end request. Sorry. Rather than sending a sign up, let's send a create to do, and rather than using email, a title and a description. Maybe just the title. Sorry, the schema right now is just the title, and then let's just log the response and then recompile, restart the server and send the request from the client. Oh, sorry. Client, you did get back a response. This does log. The important thing to know is, did the control ever reach this guy right here, and did the control ever reach here and did it lock the username? Let's go back here. I see bearer123, which means the control did indeed reach here. That's how the auth header got logged. And then I also see 123, which means whatever username the context created, I had access to that, where here in the ops.ctx.username variable. All right. This is a high level of context in trpc. Let's do a quick poll and see how we're doing. Happy to repeat. And maybe this is all we'll do today. We'll do middlewares tomorrow. Oh, not bad. Not great either. 68%. So question time. Going to open chat. Should I just push the repeat? Recap. Okay, let me first just push this code up so you can just look at it locally in case you haven't already, and then we can do a quick recap. Okay, the code has been pushed to this repo right here. You can go to 100x dev/harkirat and just go to week 14 checkpoint and you can clone this code locally. Let's repeat the context part. From a high level, let's start with how we used to do authentication in the Express world. In the Express world, the way to do authentication was, let's look at week 8 repo. Let's go to the server. There was a middleware here. What would this middleware do? It would get the auth headers. If the auth header existed, get the token, do a jw.verify. If everything was correct, it would modify the request object and do a rec.headers of user ID equal to whatever. In this was just to keep the types happy. Before this, when we did this in week 3 or 4, we would simply do rec.userid equal to payload.id. And we would modify this request object. This was a very big problem. If you see all of these if checks that I have here, the reason I had them was because a rec object does not have a user ID key. So TypeScript would complain, why are you doing rec.userid? And so as a hack, I put it in the headers, rec.userid, headers of user ID equal to this, because a request object does have headers. Now user ID is no header that the end user sent you. We explicitly put it here in the backend in the middleware. So this was the reason you need context. There you need another third thing along with the request and the response. A third thing you need where you can put all of this data. In our case, the thing that we need is the user ID. So this is how we did authentication before trpc. If I go to server routes todo.ts, if I look at the create to do route, we first call this authenticate JWT middleware. Only does if it succeeds, does it call the next function and the control reaches here. And this is how I would extract the user ID. rec.headers.userid. And where had we put this in the headers? We put it here in the authenticate JWT middleware. A similar stance here in trpc is you need to extract this from the header. The way to do it is create a context. Now, how do you create context and what is context? Just adding any third set of keys along with the request and response, any extra thing that you need for a request, you put in the context. How do you do it? Step 1 is you define the type of your context, the shape of it. What does it look like? In our case, it looks something like this. It needs to have a username, which is a string, which is optional, which means it may exist, it may not exist. If it doesn't exist, means the user isn't logged in. If it does exist, that means the user is logged in. A similar equivalent here in Express was, if it did not exist, our middleware would basically return. If it does exist, it would call the next function and the control would reach next. In our case, control will always reach the procedure, but the username key will be either null or undefined or some string based on whether or not the user is logged in. You might ask, Kirat, why? Because this is what context does. This is a middleware. We will get to that tomorrow. How you can block the request upfront and how can request never reach here only. That will be done using middlewares. What we are doing today is this logic of extracting the user ID, which is done in this global context variable. How do you create context? Again, context is just a placeholder. You call it context. It's just standard practice to call it context. You could call it whatever. State information. You could call it user information, whatever you want to call it. Context is a standard word you usually used. And if you write a Golang server, right, you will see along with the request and the response object, similar to here when you go write an express backend, you get a request and response object here. You get a third object here called context. It's very common practice to have like a context variable which contains the context of this request. How do you build this specific object? In our case, if you're using this standalone adapter, this is how you would do it. If you're using the next adapter, there's a different way to do it. If you're using the next adapter, you will most probably be using next auth for authentication. So you'll have to sort of get the authentication information from there. For us, since we're doing it using the standalone adapter, not the express adapter, not the next adapter, this is how you create context there. You add a create context function. You have the opts here. This opts has a request variable which has access to the headers. You get the header. You do all this logic that we were doing in this middleware. The jwt.verify logic. So ideally you should do all of this logic. Here, check whether or not the JWT succeeds. If the JWT verification does succeed, you should return username with the username that it succeeded with. If it does not succeed, you can just do undefined. You cannot block the request right here, similar to middlewares. That is done via middlewares. This guy's job is just extract information, get the user ID or undefined whatever. It got it, it returns it, and then you have access to that in all procedures of this public procedure, which means if you have this mutation, you have access to ops.ctx.username. And where did this come from? It got extracted from the headers, verified, and then returned here, and that's how it reached here. That was a quick recap of how you create context on the backend. What does the frontend need to do? It needs to send the header. How did you do it in our existing Web 2 world, or like not Web 2 world, our Express days? We used to send the fetch request, the URL, and here we had like somewhere we had like the headers key where we would do authorization bearer space local storage.get item token. Oh, see daisy. So this is how we did authorization using fetch when you did not have TRPC. Only extra information here is how do you send the header, and the answer is in TRPC the way to do it is, or like in TRPC frontend the way to do it is, when you're creating this TRPC proxy client, you have to define an async headers function here which returns your set of headers, or like it could also be just headers function. What does it return? In our case, it just returns authorization bearer space 123. You could also, when you have this in your front end application, your Next.js application, or your React application, you can do something like this. And you're good to go. All right, authorization bearer space local storage token. All right, this is how you do authentication and grabbing the context in TRPC. Is this part clear? Oh, great. Sometimes the recap is all you need. 88%, that is great. Lastly, let me discuss some auxiliary things, and I would urge you to kal se pehle maybe look at middlewares and try to implement them yourself. Basically try to create an endpoint which the control only doesn't reach here if the user is not logged in. All right. Right now the control does reach here. You can do checks like if not ops.ctx.username return something, but this is not great. This is why you need middlewares where you do all the authentication logic. And if the user does not exist, you sort of stop them right there. We will discuss this tomorrow, how you do it. Let's look at a few small things before we call it today. one thing is you don't have to use Zod. Zod is an input validation library. There are a bunch of others, and these guys support many of these. So you can send a different object here, and you can create a validation library of your own. You can write validation functions yourself as well. Zod is the popular one that's being used in cal.com and other sort of open source code bases. Output validators, just like you have like input validators, you also have like output validators, which basically give you the benefit of, if I have dot output whatever, z dot object id z dot string, something like this here. As you can see, this started to complain. Okay, bhai, id string is what I expect. So it gives you even like nicer types if you can upfront define this is what your output looks like. So there's no room for error as an application developer. You send the wrong set of keys here if you define your type upfront. बस यही था. These two things I wanted to discuss. इसको छोड़ के there are a bunch of small things. For example, one thing we discussed was merging routers, which means how this looks very ugly. How will you have a global router and like sign up bhi yahan hai, to do is also here, everything will be here? And the answer is no. You can create routers separately and you can finally merge them. So let's look at a quick example. Merging with t.merge routers. So let's say you created a post router that has like a post create. Post is like Facebook post, Twitter post, and a post list. These two functions it has. And you create a users router which has a user list. You can add like the sign up, sign in, all of these things here. Finally, what you can do is const app router equal to merge routers, this and this. And this you can define in a different file. For example, they have defined it in routers/post.ts. This you can define it in routers.users.ts. So you can structure your project well and then finally just merge all the routers rather than defining everything in a single router. All right. Someone also pointed this out. So great. So we have done this, we have done this, we have done this, we have done this. Context also we have done. Middleware is the last thing we need to do before we can say we know well. We have also done authorization. So we're sort of a step ahead. Isko chhod ke there are a bunch of other things. Data transformers is something we should probably do as well because cal.com uses like a data transformer. And the other big thing we need to do. So the big things we need to do tomorrow is one, middleware. So urge you to try this yourself. Two, Next.js. How does this happen in Next.js? Because cal.com uses Next.js. That's what they use. And lastly, data transformers and what they do. And there are a bunch of other things you can, if you want to look at it, they're like a Next.js integration. How do you integrate the client with the Next.js? It might be a little different from how we have done it here. So I might have been said this before. Okay, this might just work out of the box in React. It may not. You might have to follow this setup procedure for it to actually work. And this I saw in the morning in cal.com code base as well. Then vanilla client is something we created, which is simply like this HTTP batch link and trpc-client. And then, yeah, a bunch of other things. They also have a course and cookie section for whoever was asking. But again, if we're using Next.js, we'll be fine. We don't have to worry about course. Cool. That is today's class. Opening the chat for any questions related to the class or otherwise. There we go. Pause. Seems like the create context looks similar to middleware. It looks very similar to middleware. Very thin line, but there is a very big difference, which is its job is to fill the context of the application, which is username, database, Prisma, Mongoose, things like these. Its job is not to stop the request at some point. Middleware's job is to stop the request in case it does not follow certain criteria. But this guy's job is just to fill everything rather than stopping the request at all. So there's a very subtle difference. There's a big difference, right? This is not supposed to and cannot prevent requests from going further. Middlewares can. And you could argue that I will do all of this in a middleware, and I would say yes. But like usually contexts are sort of created in a single place, and that is how it's done in cal.com as well. So we need to really follow that so that our journey is easy when we're starting to contribute. Difference between gRPC and trpc. Very big difference. In gRPC, there's like a very long file that you define, very similar to the OpenAPI spec, where you write all of your types and what your inputs and outputs look like. gRPC is very opinionated in how you send data to the server using something called protobufs. Here, if you're using trpc, you can actually use these transformers. Data transformers to describe how you want your data to go from your client to the server, be it JSON, be it gRPC or sorry, not gRPC, protobufs or whatever your format you can define over there. It's slightly gRPC is slightly opinionated, but gRPC works with any language. TRPC, TypeScript is in the name, so only works with TypeScript. So that's why gRPC is a little more favorable. I'm able to understand every library pretty well. It's just that we are creating our code in a certain way which differs from how it's structured in the real world code basis. Can you make a class explaining the best structure in libraries? Yeah, so that's the thing, right? We're doing, because we tried this once when I was creating a big project. I already had to do application, and then we started to integrate it there. It becomes a little overwhelming. So we are doing it slow. And then when we open the open source project is when all of this should hopefully come together and you should be able to understand. And I feel that's where a big woe will come. Oh fuck, we went from such a small project to such a big project. But to answer your question, that is when we will cover this is how the same thing is done in a bigger sort of code base. All right, how to send status codes. So there is a way to send status codes, even though status codes sort of sounds weird for RPC call, but you can actually send a list of a few status codes. If you go to the week 14 class, where I had a bunch of extra things other than what we discussed today, which is like I actually connected to a MongoDB server, all that jazz. Here you will see RPC error. I think I created a middleware. So we'll discuss this tomorrow, basically when we create a middleware. If the request sort of fails in the middleware, we return a TRPC error where you can define like a status code. TRPC.js middleware. There you go. So this is the way to return like an unauthorized code base. But if you go through the types of this thing, you will see there are only like 6-7 status codes that it sort of supports. But if you use this, it'll get like a 403 on the client. Sign up API shouldn't be authorized, but create to do should be authorized. Can we create context per API? Yes, you can. You can create separate routers and do what you're asking to do. And the same, so if you go here in, basically, yes, you can do this. Here in middlewares, you'll find a way to do this as well. Define procedures separately. Extending middlewares. Yeah, I'll cover this tomorrow. You're supposed to cover this tomorrow anyways, but yes, you can specify this middleware should, you can specify that for middlewares. Actually, I'm not sure if you can do that for context. Here is where a concept might come of inner and outer contexts, which maybe does what you're asking, but that is a good point. You will never have the sign up information will never have an auth header, so why even do this? And that is a good point. And I don't know if you can do that separately for contexts, but I feel you can if you use this inner and outer context, but I could be wrong. We'll discuss this tomorrow. Good question. Give an overview of how TRPC works when the backend is in Next.js and the client is also Next.js. Yeah, so the code looks exactly the same, which means this whole part you can just repeat, but the adapter that you're using looks different. Also, you have a full-blown Next.js application here on the left. In the Next.js application, you have pages/API/TRPC/TRPC.ts. Basically, you give TRPC access to a certain backend route, and that's where all your TRPC sort of calls happen. You can actually go through, which we'll go through this tomorrow, but if you can go to hosting TRPC with adapters and go to Next.js here, it will basically tell you the steps of how you can do the same thing in Next. How to determine post or patch or delete. So that's the thing. It's either get data or put or like modify data. There is no post, delete, puts are all a mutation. Get is a get. So you don't have to create the distinction between these three in this or in GraphQL also. So context comes with inside header, or is it something completely different? So context doesn't come inside header exactly. The header only has a token. You extract from the header the user information, basically do a database call here or do a jwt.verify here. You get the user's ID and then you return it here, and that's how the context is created. You don't get the context in the header. You only get the authorization token that the user got when they signed up or signed in. And using that, you get the information of the user and return it. Can you explain public on clear information? Not what it is. Can you explain public procedure? Clear on implementation, not clear what it is. Okay, it is just a variable. T.procedure returns you a variable. So what will happen in the future is you might have, as someone said, some endpoints need to be, let's say, admin gated. Other endpoints need to be gated just for users. And maybe there's an endpoint that's completely open. You don't need to be logged in. So what you can do is you can create different procedures, public procedure and then admin procedures. That's why you can define them separately, and you can be like, by this one has a specific middleware, whatever is the syntax to do it. Admin procedures have a specific middleware, public procedure have a different middleware, and then maybe have no middlewares. And then there's a user procedure which has a separate which has its own middleware. And all the routes that you define here, all the procedures that you define here, go through the middlewares for the user, which basically means extracts the token information and make sure that this is an actual user on the website. Similarly, for admins, you extract the information and make sure they're an admin. And this is a public procedure. So that's the high level use case of this procedure, that you can create different ones and provide different middlewares to each one of these. And whenever you're creating your functions, this guy runs no middleware, this guy runs the user authentication middleware, this guy runs the admin authentication middleware. This is something you can read about here only somewhere. Somewhere here I read this in the morning only, but yeah, that's a high level difference of why you need T.procedure. For today's class, you just need to understand this is what lets you define and create procedures of your own. It was use, the syntax I suddenly remembered. So it can be like T.procedure.use middleware admin or whatever, middleware user, and then middleware admin, so on and so forth. And then this, whatever calls you create for the user procedure, whatever functions you create for the user procedure, go through the user middleware, and then public procedure go through no middleware. And that's why you have like separate procedure handlers for specific functions. That's the high level need for this T.procedure variable. Can you do 5 minutes through cal.com's code base for TRPC? Chalo bhai, ye baat ki na tumne sahi. That's a good point. So this is, I went through this morning only. So cal.com/cal.com. If you go to packages/trpc, you will see a few things here. The important thing, the first thing is the index.ts file. No, not this. Server index.ts, trpc.ts. So this file, as you can see, has merge routers, the thing that we discussed. Middlewares, forget. T.procedures, trpc context is init trpc.context. What is the context that these guys use? So let's look at their context type. Create context inner. So this is one very nice thing they do. How did we do this thing? Ki username string maine yahan dal diya. I put ki the type should be username string. I could have simply written type of whatever this function returns, right? Which is my create context function. If I'm able to put this in a separate function, and I can simply write type of whatever this thing returns, it's much cleaner than me writing this, because then I have to define the object here. If in the future this thing changes to whatever age 12, then I have to make that change here as well. That's what they do. They say type of create context inner is the context that they've created, dot create, and they also have a transformer, the thing that I said we'll discuss tomorrow. Basically, transformer, when you're sending data from the client to the backend, lets you transform data. In this case, they're using this thing called super JSON. The idea is there are like very complex objects in JavaScript. For example, there's this date object, and it's an object in itself, right? It has functions associated with it, get date or whatever. So you can't really send a JavaScript object over the wire over the network, right? You can send numbers, you can send strings, you can send simple objects as well. You can't really send an object which has methods inside. That's weird. You can't really send that over. How would you serialize it? How would you deserialize it? Super JSON basically lets you send things like these, and like the way they do it is, you can read through their, we'll discuss this tomorrow, you can read through the documentation. But let's say there's a complex date object. This is what they send. Ki haan, JSON date looks something like this, and meta, ki bhai, this is a global date variable in JavaScript. So rather than, you can basically, whenever you're calling on the client, whatever title, you can also send like the date as a native date object, versus if you were doing this in the Express world, you would actually convert this into like a Unix timestamp, which is like a number, and send the number to the backend. But if you use Super JSON, which is a transformer, then you can send like these native JavaScript objects over the wire. Effectively, what's going over the wire is a string like this, but it gets deserialized on the other side as a date object. So that's what this transformer is. What we wanted to cover tomorrow, but like basically this is what we wanted to cover. This is how they've created their TRPC context. This is how they've created their router. They do one very weird thing here, which is this unstable handler cache. I don't know why they do it, but if you look at it, the bigger file that has it, basically import handler. Let's see what this function is. Like, they don't import all the routes immediately. They sort of load them. Okay, they've probably written why they do it. This function will import the module defined in the importer just once and then cache it for default exports. So like some sort of caching they do here, and I think they do it for like routes or maybe something else. I don't know. Okay, but anyways, important thing to know here: create a router, have the merge routers function, export that. This will discuss tomorrow. Export the middlewares. This is what's present in trpc.ts, similar to how our trpc.ts exports the router and the procedure. Their trpc.ts exports const, procedure, and the router. Is this part clear? Hopefully it is clear. Let's look at how they create a context, and then there is a create context method here that they use to create context. And as you can see in the create context, they do return Prisma, the thing that I was talking about. Okay, usually whenever you're creating your context, let's go to here, you return DB or mongoose or your Prisma variable here so that you can mock them in tests. That's what they're doing here as well. Okay, they return Prisma along with a bunch of other options. Now here is where they use sort of inner and outer context, which is something we haven't discussed right now and we can discuss tomorrow. And yeah, it's also useful for testing. Inner context will always be available in your procedures in contrast to outer context. And then what is outer context? So whoever asked the question of how you can have different data for per context or like per route, different context per route, this might be your answer. That's what outer context might be for. I don't know for sure, but reading at this line, I feel that's what it might be. All right. So this context, create context variable, what does it do? Gets the locale from request. What is locale? Whether this user is using English, Hindi, all that jazz. This is also something it is good to have access to here in your handler, because let's say the user has a to-do. If you have access to ops.ctx.locale and you know it is whatever Hindi, then you can convert whatever strings you're returning to Hindi before sending. So that's another very common thing for you to put in the context of the application. Finally, there is session, which is the user information. Session getter is a function that somehow using request and response gets the information of the user. And finally, what does it return? It returns everything from the context inner function, which is Prisma. And what are the other things we're sending here? Locale and session, which are the two things we defined here. That's the context inner. And it also returns rec and res also. So it basically returns the whole objects in the context, has access to request, response, and the complete context here, which is Prisma as well as locale and session. थोड़ा समझ आया ये कि how they are creating context and how they have Prisma also there and then locales also there and then the user information and how their TRPC initialization is happening. थोड़ा cool. It will be good to do this in a more structured fashion. I'm like looking at the code very ad hoc here, but let me show you how they use it in Next.js. So this is how where they've defined their woe, and they've also defined a bunch of sort of routers here, procedures, auth procedure uses probably some is admin middleware. So there is a auth procedure, which is again just a t dot procedure. But the thing that I was discussing here, which was user procedure can be t.procedure.use the middleware for the user, and then admin procedure can be t.procedure.use the middleware for the admin. And if you look at the auth procedure here, it has public procedure.use, ignore this, .use is admin middleware. So that's where they've defined their two sets of procedures, a user procedure and an admin procedure. Finally, where do they have their routers? So here you will see a bunch of routers, basically a bunch of handlers. Public viewers, let's look at whatever country code.handler.ts. What does it look like? Get the request object from the context. As you might remember, the context had the request, the response, the locale, the session information. Get the request, the whole thing here. And then from this request, you can actually get the user's whatever country code, request.headers.x Vercel. Whenever a user is sending you request and they're hosted on Vercel, they most probably send you this sort of country in their header, and you get access to it, and then you can just return it to the user. So country code handler is something that user can call. When they call it, what do they get back? Their country information. Similarly, let's look at a better one. Routes logged in viewer. Let's look at what things logged in user can do. They probably want their avatar information and want to update their avatar. So this just returns the user's avatar. So one thing you can do, the avatar handler. So again, they're just defining some functions here, which is like this thing on the right, maybe not even that, just the handler they're defining. And then all of this .input.mutation is probably done where, actually I have no idea, I'll just have to Google it. Anyways, good question, and this is something we will cover eventually. Let me just quickly show you one thing here, which is how TRPC is used. This is their final web application. If you go here, pages, API, TRPC. Here is where all the routers are defined. There you go. So let's look at bookings. TRPC.ts. Create next handler booking router. So this is how you use do TRPC, like basically this thing. Create HTTP server. Similarly, how you do this in Next.js is create next API handler, and for this specific /bookings endpoint, the router where the control will go to is this bookings router. Let's look at the bookings router. It looks something like this. Bookings router is router which has a get function, which is the auth procedure dot input, the input schema dot query, and then does a bunch of logic to get the bookings for this user. So this probably is a very important procedure for cal.com. Okay, get, I mean, this may or may not be that. From what I can get right now, this is that. Get all the bookings for a user. How do you get it? There is a booking router which has a get function which checks whether or not the user is logged in. That's why the auth procedure, which has a middleware associated with it. Dot input makes sure that the user is sending the right input to you, which is, let's look at what is the schema that they expect. Get.schema.ts. Filters. What all bookings do they need? For what team IDs do you need the booking? Most probably this is the admin that's sending the request to get all the bookings for a bunch of users, where the user IDs are this. Limit and cursor are like pagination inputs, if you understand that a little bit. So I'm going a little ad hoc here. And finally, if you look at the handler, the router, you will see it. What does it do? Unstable handler cache dot get. So here, like I see this a few times in their code base. I'm not exactly sure what it does, but from what I can get, it sort of caches a bunch of, for example, the get dot handler it caches. Yeah. So this is that the thing that actually handles most probably getting it from Prisma. So if you look at the get handler, take, skip, if you might remember these from the class of Prisma, and Prisma dot see. Yeah, I mean somewhere here maybe it has the, not maybe, like most probably it has the filter. Where do you do the call? There you go. Prisma dot booking input equal to this thing, booking select. There you go. Prisma dot bookings dot find many. Again, it's a very complex object that they're searching and complex select that they're doing, the things that they're trying to select from the database. But this is where they're finally sending the Prisma dot booking dot find many query. Find all the queries for this user. So they've like broken down the thing into three parts: the handler, the schema and then the router. But ठीक है, ये बहुत ज़्यादा आगे हो गया. Whoever asked this question, good question, but like we will get to it when I'm a little more prepared and we don't go this ad hoc. But yeah, these are the two folders you're going to look at if you want to look at how cal.com uses trpc, which is the /packages/trpc folder. And then if you go to their web folder here, apps/web is where you will see how they're exposed via Next.js, which is something we'll cover tomorrow. But yeah, pages, API, trpc. So these are the two folders I would look at if you want to understand a little bit of what we've learned and can I understand that in a big code base. One is this folder, other is the packages/trpc folder. Cool. All right. What resources do you use to learn Golang? I just wrote servers in this framework, some Gorilla framework in Golang. And then there's a very nice 30-day Golang, 30 days of Go. No, it's not this, but like one of these sort of things that I used to learn from. Learn Go by doing, ऐसा कुछ है. I don't know. But yeah, that's how I learned Golang. Cool. Chat open again. Pause. Golang Rust mini series when we'll launch it on YouTube whenever sort of we get the time. Can we use Axios React query with trpc? You can use React query, but again under the hood it is still sending like doing RPC calls. You can most probably not use Axios React query. Also, I'm saying you can use, because I saw an adapter here somewhere in the client usage, React query integration. So you can use React query. You cannot use Axios. That's for sure, because like that's an HTTP this thing, right? Like you can use Axios in the sense that you want your end client to send requests using Axios and not fetch. Maybe there's a way to sort of put it there, but you're not really worried about that as the application developer. You're just doing RPC calls. Post patch delete will be required for different MongoSQL commands. So in mutation function, don't we need to know? No, right? So it will be required in SQL call, but you as the application developer know, okay, this is a create to do endpoint. Even though it is a mutation, you know it is supposed to create a to do. Okay, similarly, when you define delete to do endpoint, even though it says mutation, you know it is supposed to delete from the database, right? So you send the delete request to the database. So even though there's no high level like route types defined, there's a get or a post route, you know based on the name what this thing is doing, and then you can do the right MySQL or MongoDB calls. Context wasn't that much clear. I will cover context again tomorrow before we start middlewares. Although I feel like 85% ko clear tha, so I would urge you to go through the recording again before, and then we can discuss this tomorrow if need be. Okay, there's some this thing here about, okay, cool. Can we define the context inside the middleware rather than route and use it for specific routes? I don't think so. Might be possible, but I don't think so. I don't think you can change/modify the context because it has very heavy types, right? If you try to change the context or like add context in a middleware, I don't think you can do it. Or if you try to do it, it'll complain. Or if you are able to do it somehow, it's not good practice for you to update the context variable in the middleware. It is here that you should create the context, is what I feel. So trpc is types and everything compile time. Still there can be runtime errors if we send incorrect data, right? Yeah, but the thing is your client won't compile if you send incorrect data. If I try to send, if I try to send this here and if I try to compile my code, it will just complain, right? It will fail at compilation. My date doesn't exist. It will make me send data. Now you might be like, I'll send, I don't know, whatever, very long string or something else that corrupts the database or whatever. I agree. But a lot of errors it will catch at compile time for you. For example, if I try to send an object here, it will be like, no, cannot. Even on the client, even though these types were defined on the server. Is cal.com going to be one of the repos that we contribute to the cohort? Most probably no. There are a few reasons for it. But I'm covering everything that's needed there. We can also do a class or two, but we want to go very deep in one repository or two, whatever. And one, cal.com has a lot of people contributing already, and two, it's very complex of a project, but I'm happy to. But I for sure know that people get overwhelmed there, versus if we pick a slightly smaller project and break it down into various portions, might be easy to understand. So it's up in the air. I'll leave it to you guys. I'll put out like 4 or 5 open source projects, whatever you want me to. We can go through it. Got overwhelmed in the last 5 minutes. Last 5 minutes is good enough. I hope that either means, so if you got overwhelmed in the cal.com code base, don't worry about it. That was just an extra exercise we did. You don't have to understand that yet. But if you got overwhelmed in the context part, please try to go through the video again. Yeah. Is the localhost URL in client.ts the one where Trpc server is running? Yes, that is correct. So it's running on port 3000. If you go to server/index.ts or this thing right here, server listen 3000, so that's what it's running. All right, cool. Any more questions before we call it? Probably the last set of questions here. How to deploy Trpc? You just start the backend server, right? I just ran what node this/server/whatever.ts. That's what you run on your AWS server. If you're using Next, then it just deploys if you use Vercel. Cal.com part, ignore. Just a very ad hoc session of just thoda seeing ki what we learned today is used there. Even I was trying to understand this as time went by, so it will be very hard for you to understand it, considering it was very hard for me to understand it as well, right? So we'll get there when we get there. Since tech is changing rapidly, you will learn new tech immediately, or would you feel it's good to go with new tech just like Trpc? So it really depends. Again, it depends on the project that you're using, right? If you're leading the project, then you do whatever you're comfortable with. If someone else is leading the project, whatever they're doing, you have to sort of understand it. So go by example. Yes, sir. Thank you very much. So Tarun Kumar, go by example was the library indeed that I was sort of thinking about. Sorry, the place where I learned Golang from initially is this Go by example website that sort of lets you learn through very basic examples. For example, how do you do pointers? How do you do file reading, rate limiting, so on and so forth. So very nice resource to learn Golang. Cool. I think we'll have to call it here. 9:20 and battery. And we have battery. Any more questions? Considering we learn so much from now on, what should be the path to at least to get a job? So at least start contributing now. I think you have enough context to struggle through a code base and start to solve things. Especially this or double.sh, like you have literally, we have used almost similar stack. At least step one can be at least setting this up locally, making some changes, and then from there you do whatever, like start contributing. But dub.sh, cal.com are two code bases jinka jo bhi stack hai, we have covered a lot of it. And at this point, I would urge you to start to clone projects, make changes in them, and put out open source contributions. And then job has 10 different factors that sort of lead to a job. But at least you're on the right path if you can start to contribute now. And if not, that means it's a long way to go if you want to get hired in remote jobs by open source, all that jazz. All right. Is it okay to have 6 to 9 months gap in resume after grad? Okay, that's fine. And I'm a junior developer with only less than 2 years. Should I leave my job if I get admission to GSOC? I mean, why do you have to leave your job if you got into GSOC? Do both the things, right? There's no downside in it. All right. Thank you, everyone. Thank you for joining. And I will see you guys tomorrow where we covered middlewares and how to do this in Next.js. All right. Bye-bye.